So, welcome to this problem on chemical kinetics. So you are asked to determine the order of the reaction, and this particular method is called as variable initial concentration. Uh, so, the experimental table is given here in this table, and essentially what they have done is they have kept the reactant concentration in this for this particular reaction H2PO2 minus plus OH minus liberating hydrogen plus HPO3 2 minus. So what we have done is they have done four experiments. In the first experiment, they have kept the constant of the concentration of H2PO2 minus has been kept constant, and this is they are varying. In the second experiment, they have kept constant the initial concentration of OH minus, and they have varied the H2PO2 concentration. And you have checked the influence on the rates of the reaction. Of course, you can see that rate of the reaction has been varied, and you are asked to determine the order of the reaction. So let us solve this step by step. This is a very important problem, and your options are here. What is the overall reaction order? Whether it is first order, second order, third order, or fourth order. This type of questions usually comes in jam also. So let us solve it in a better manner. So let us see for all these we can write the rate equation also. For the first experiment, the rate I am writing it as rate 1 will be equal to K into concentration of H2PO2 minus. Let that order with respect to H2PO2 minus be EM, and then it should be multiplied by concentration of OH minus. Let the order with respect to OH minus be N, so that this is equal to 2.3 into, and your unit is 10 to the power of minus 3 dm 3 m minute minus 1. I'm not writing that one. Now for the second one, you can write it as similarly rate 2 will be equal to again K into concentration of H2PO2 minus to the power of m and OH minus to the power of n, and that the rate has been increased to 9.5 into 10 to the power of minus 3. So let us divide the equation 2 divided by equation 1, that is rate 2 divided by rate 1. So this will be equal to K into the concentration of H2PO2 minus, they have kept it as 0.6. So 0.6 to the power of m, and here it is 2 to the power of n divided by K into 0.6 to the power of m, and this is 1.0 to the power of n will be equal to 9.5 into 10 to the power of minus 3 divided by 2.3 into 10 to the power of minus. So what we'll be getting is this cancels, and this will be 2 to the power of n. 2.3 9.5 by 2.3 is approximately come to 2.3 into 4, so that will be 4 points 2.3 into 4, it will become 9.2 around, so this is approximately 4, so this is 4, so n is equal to 2. Similarly, you can write the equations 3 and 4. So if I write the equation 3, that is rate 3 will be equal to K into, here that concentration I am directly substituting, so it is 0.1 to the power of m by 6.0 to the power of n will be equal to 14.4 into 10 to the power of minus 3, and the fourth one will be rate 4 will be equal to K into 0.2 to the power of m into 6.0 to the power of n is 28.7, so into 10 to the power of minus 3. So what will be equation 4 by equation 3 will be equal to so this is, I am simplifying it, 0.2 to the power of m divided by 0.1 to the power of m will be equal to 28.7 into 10 to the power of minus 3 by 14.4 into 10 to the power of minus 3. 14.4 and 28 point is approximately it will be equal to 2, and this point 1 by point 2, that is will be 2, so 2 to the power of m is equal to 2, so that m should be equal to 1. So you have got m is equal to 1 and n is equal to 2. So what will be the overall order? Overall order will be equal to m plus n. So this will be equal to 1 plus 2, that is equal to 3. So once you check the correct option, it will be the third option.